Welcome to my lecture, Coastal Management a Systems Approach. My name is Johanna Schumacher and I'm a scientist in the Coastal and Marine Management Group at the Leibniz-Institute for Baltic Sea Research and also at the Marine Research Institute of Klaipeda University in Lithuania. In this lecture, I will introduce you to the systems approach framework. I will use one case study in Lithuania to guide you through all the steps from the issue identification to the monitoring and evaluation, and then I will end with a summary. Coastal systems are complex, and in order to be managed in a sustainable way, a holistic approach is needed. And because of this, integrated coastal zone management, or ICZM, was introduced in Europe in the 1990s as an iterative and multidisciplinary approach that promotes sustainable development of coastal areas. And it also defines principles for sound management and planning. But in a review of existing ICZM case studies, we saw that there's weaknesses. For example, a lack of a holistic approach was common for many of the case studies. And this then led to one sectorial solutions. It was also shown that stakeholders are often engaged only late in the process and that stakeholder groups were often not balanced. And this can lead to public protests, which delay the implementation. So in many case studies, it actually took a long time from the identification of a problem to the decision on a solution. So what we can conclude from this is that despite a large amount of literature on integrated coastal zone management, the concept actually remained rather vague, and that a systematic and stepwise approach is needed in order to allow for practical applications. The systems approach framework that I will introduce in this lecture is a holistic approach which is based on systems thinking. And in brief, systems thinking is about looking at the whole system as opposed to single parts or pieces of it. And when I speak about systems, this always includes the natural system on one hand, but also the social and economic system. So the systems approach framework that you can see in this figure, it provides a systematic and stepwise guidance to address an issue. And issues can be caused by changes in human activities, changes in the ecosystem itself, and also by policy changes. And these, again, can be caused by external factors. The core of the systems approach framework is the ecological, social, economic assessment that you see on the left side of this figure. The ESE assessment breaks down the ICZM cycle into 6 concrete steps. And it ensures that stakeholders are involved throughout the entire process. And as you can imagine, the SAF cannot be applied by a single person, but it is actually a teamwork. So the groups that are involved in a SAF application are, on the one hand, the SAF core team, which consists of a team leader and a group of interdisciplinary scientists, so from different disciplines. The governance group, which is often authorities or agencies that are responsible for policy implementation, and the stakeholder group. So these are the people that are affected by a problem or by a solution, and also those that caused the problem. So with this group, the SAF integrates scientific evidence and also local knowledge of stakeholders into decision making. I will now go through the 6 SAF steps, and I will use a case study to show how it is implemented. And the case study is about establishing beaches at the Curonian Lagoon coast. So to provide you some background, it is the most popular tourist destination in Lithuania, but the problem here is that the tourist season is rather short, so it only lasts from around June to August. And this then leads to low-income jobs, which is an indicator for unsustainable tourism. And therefore, there's a very strong need to extend the tourism season. Also, bathing tourism in Lithuania is very much concentrated on the Baltic Sea coast, and the Coronian Lagoon that you can see on the map. There's only one official beach in the area. And so far, the water quality or the insufficient water quality has hampered bathing tourism. But with increasing nutrient load reductions and also improved water treatment in the area, also the water quality has improved. And this provides the opportunity that the area could be used to also establish beaches in the area. So the case study assessed whether it is feasible to establish a bathing site within the Coronian Lagoon coast, and also if the SAF is suitable as a tool to guide the process and implement the ideas of integrated coastal zone management. I will start with the first step. It is the issue identification. And in this step, you list the human activities, you identify potential issues, you map the institutions and stakeholders relevant for your issue, you map the ecosystem services and stakeholder preferences, and then when you have several issues, you prioritize and select the most important one, and you identify the relevant environmental, social, and economic elements. So in the end of this step, you should have decided whether a full SAF application is needed, and you also formed the core SAF team and identified the key stakeholders involved. The issue identification in the case study started with a discussion and analysis of potential problems and also with a review of the plans in the area. So first, an interdisciplinary research team was established, and they mapped the key stakeholders and institutions. This included state ministries and agencies, district representatives, the Tourism Association, the local mayor, fisheries, nature protection NGOs. And supporting tools were applied. I will not go into details about this, but this will be part of another lecture. But in general, it was used to assess the causes and the effects of the problem and also to map stakeholders. And the results of these applications were then taken to the first workshop and discussed with the stakeholders. So outcome of the workshop was that the group considered the beach establishment to be of high relevance, and there was also very strong interest of the stakeholders. So they saw on the one hand the opportunities that the beach could have, for example, that it could be attractive for families and especially children and elderly people because of the lower waves and currents and the rather shallow lagoon in comparison to the Baltic, and also the opportunity to extend the season. But they also had some concerns, and the main concern was that an insufficient water quality could lead to temporary beach closures, and this could lead to a loss of reputation for the municipality. So because of the high interest and these controversies, the SAF was found to be very suitable. The next step of the SAF is then the system design. And in this step, you develop a conceptual model, you identify the linkages between the different components, you assess what data and resources and modeling methods you have available, you define the boundaries of your administrative and virtual system, you identify external hazards that might affect your system, and you define criteria which you will later need for monitoring. You assess the current state of the system, and you ensure that all the stakeholders are incorporated into the process. And you already discussed potential management scenarios with the stakeholders. So at the end, you have developed your conceptual model. You will see in a minute what this looks like. You identified the linkages and the boundaries for the system that will be analyzed. So here you see the example of the conceptual model that was developed in our case study. And it consists of an ecological component, which is shown in blue, and an economic component. The ecological component provides information about the spatial and temporal distributions of E. coli concentrations. And E. coli is used as an indicator for bathing water quality. The economic model looked at the costs of establishing a beach. So, for example, the cost for maintenance, but also establishment of infrastructure, and at the additional benefits that it would provide. So what you can see from this as example is that tailor-made approaches are actually needed for each case study. So it's not a one-fits-all solution, and that you need different types of models. So it's not only numerical models that can be used. The next step is then the system formulation. This is a rather technical step. Here you assemble the data inputs and variables, you formulate, document, calibrate, and validate the individual components, you discuss them with the stakeholders, you link the components into a complete model, and you test the sensitivity and validate the model if it's possible. And you start running the scenario simulations. So at the end, you should have an integrated model and first results for the analyzed scenarios. The systems formulation step in the case study started with the discussion of the model components within the stakeholder group. And here it was already decided that the virtual system could be restricted to the Curonian spit, because bathing sites along the mainland coast of the Curonian lagoon were not so much of interest. So the next step was then the definition of alternative scenarios. And here an approach was used where with decreasing spatial scales. What this means is that for the beach locations that were assessed, the scenarios looked at the entire Curonian spit coast, while the microbial pollution and the beach establishment were then focused on the on the town of Nida, because this was the most suitable location with respect to the bathing water quality analysis. And in the microbial pollution risk scenarios, it was assessed how wind and river loading charges would affect the area and could pose a risk for temporary closures. And in the beach establishment, different costs for infrastructure, maintenance and marketing were considered. And it was shown that this spatial downscaling was actually quite beneficial for the stakeholder process, because this way they could, the problem or the issue became more concrete. The next step is then the system assessment. And in this step, you prepare the scenarios for the stakeholders, you visualize the consequences of the results, and you conduct stakeholder meetings to discuss the results and potential management options. So at the end of the step, you should have a good overview about the consequences of different measures, and also an idea about the perception of the stakeholders with respect to the different management options. In the system assessment in the local case study, the results were presented and discussed with the stakeholders. It started with the results of the bathing water quality. So here, the sampling and modeling results showed that there's actually a low risk of insufficient water quality in the area. And also the pollution scenarios showed that distant pollution sources, for example, inputs from the river, do not pose a threat to local beaches, but that only local pollution sources might be problematic. So that only a breakdown of the local sewage system could actually lead to a temporary beach closure due to increased E. coli concentrations. So the results showed that the conditions to open a beach in along the Curonian spit, and especially in the town of Nida, are actually favorable. A survey about the tourism perception and acceptance provided some interesting results. So it was shown that nature activities are actually more important than water activities. So the main reason why tourists visited the area were to go for walks or to visit places of interest. And bathing in the sea, and especially in the lagoon, were not the main priority. The survey also showed that the benefits that a beach in the lagoon site would have are not the main factors why people choose a beach site. So this would mean the higher water temperatures or the shorter distance to town. Instead, factors like no smell or the absence of dead animals and pathogens are much more important for visitors when choosing a beach location. So the results of the survey showed that from a visitor point of view, a lagoon bathing site would actually not be the first priority. The respondents were also asked what additional services should be provided in order to increase the attractiveness of a beach site at the lagoon coast. And they said that showers or also SMS alerts about the water conditions would be beneficial. And for these services, they would only pay up to €1. Additional services included, for example, lockers or open-air movies and a solarium, or water tourism and snack places. And for these services, people were willing to pay around €1 to €5. So from this, the maximum potential annual income from a beach was calculated and compared to the costs. And what we saw from this was that theoretically, after several years, the costs could be compensated. But that actually it's more realistic that the establishment of a beach would lead to additional costs for the town of Nida. The results were discussed within the stakeholder group, and also alternative scenarios were discussed. The ones with the highest priority were nature trails and environmental information, but also advertisement and reduced prices and events during the off-season. But the stakeholder group actually did not see these as real alternatives, but rather as complementary scenarios to the beach establishment. So in the end, they actually agreed to utilize part of the coastal strip of the town of Nida to open an official beach. And they said that first this should be a low-cost beach, so without additional infrastructure or beach nourishment, to just see and analyze the acceptance of the local community and also the visitors. So after 1.5 years after the initiation of the SAF process, they actually came to a decision to open a beach. If the systems assessment led to a decision, then the next step is the implementation. Otherwise, this would be the point to reiterate the SAF cycle or at least single parts of it. If it comes to the implementation, the actions that you should take are to specify regulatory and financial requirements, you obtain legal permits, you identify mitigation measures that might be needed to offset negative impacts, and you ensure that the public is informed about the decision. You also validate the decision within your group. And at the end of this step, a policy decision has been made and implemented. In our case study, a public announcement was made to open a beach in the town center of Nida. And to support the establishment, the bottom at the bathing site was cleaned up to a water depth of 1.5 meters. And an additional mitigation measure was implemented, and that was a floating macrophyte line with the idea to absorb nutrients and to mitigate potential eutrophication effects. The final step is then the monitoring and evaluation. And here you ensure that the required mitigation measures are implemented, you agree on the indicators used for monitoring, you evaluate the need for additional data requirements, and you evaluate whether mitigation measures are effective. You assess if the objectives were reached, and you ensure that the communication with the stakeholders on the progress continues. And in the end, you again evaluate if an iteration of the SAF is needed. And what we can say here is that the monitoring can start immediately after the implementation of a measure, while the evaluation usually takes place beyond the time frame of the SAF application. In our case study, it was agreed to also conduct a monitoring, and this included, on the one hand, the water quality, but also visual nuisances were observed. For example, the presence of dead fish and algae blooms. They assessed smells and also litter and beach wreck at the bathing site. And it was found that during the majority of the monitoring days, there were actually dead fish present at the bathing site. And at one point also an accumulation of dead beetles caused quite a strong smell and time-consuming cleanups of the area. The water quality monitoring further showed that there is an increased concentration of cyanobacteria and also Vibrio, which is a human pathogen, were partly found in the location. So it was also shown that the mitigation measure, the floating macrophytes, they did not lead to the anticipated changes. So in the end, the legal permits to open a beach were actually not obtained, and this shows that an iteration of the SAF would be needed. And with this, I will come to the summary to conclude what we have seen and learned in this lecture. So we can say that the systems approach framework is an important tool to implement the ideas of ICZM in practice. It breaks down the ICZM cycle into 6 concrete steps and provides actions and supporting tools. And it ensures that stakeholders are involved from the very onset of the process to the very end. And this can then help to shorten the time frame from the identification of a problem to the decision on a solution and its implementation. The practical application in our case study showed that the SAF is suitable, especially in cases with high stakeholder interest. It also showed that it's not a one-fits-all solution, but that actually a tailor-made approach is needed for each case study. In the case study, the spatial downscaling was considered to be quite beneficial for the stakeholder process because it made the issue more concrete. And we could see that a full SAF cycle can be implemented within 12 to 18 months with an experienced team. And finally, the example showed quite nicely that SAF is not a linear process, but that iterations of single steps or sometimes even the entire cycle are necessary. And with this, I would like to thank you for your attention.